Let's take a look at page 16, which is the warm-up for your first quiz in this unit. I'd like to remind you of a couple quick things first, which is that you should always look for how many fractions you're going to need. If the problem uses moles and moles, one for each chemical in the problem, versus if the problem uses moles and grams. Moles and moles is going to mean it's a two-fraction problem. Moles and grams is going to mean you're looking at a three-fraction problem. So when we go look at number 1, it says given the what is the total number of moles of Fe2O3 needed to produce 4 moles of Fe? Well, moles and moles is a two-fraction problem, so we can draw our two fractions right away. We also need to draw the mole bridge. They're starting us with 4 moles of iron, so that's where I'm going to start my bridge. And that's also going to be the given that I write over 1 on top of my first fraction. They are asking about total number of moles of Fe2O3, so that's where my bridge is going to point, over at Fe2O3. And this will be my bridge for problem 1. Next, we know that what goes up must come down, so I'm going to put moles of iron on the bottom. Remember that once you have a number of moles on the bottom, you are ready to use your bridge. That's the fraction where your bridge is going to go. Also remember that you can only use moles twice with each chemical for a total of 4 times. Well, we've now used it twice with iron. I need to use moles 4 times total. Here it's moles of iron and moles of iron. I can't use it with iron again, so I'm going to have to be using it with another chemical. And if we look at our bridge, the bridge is starting at 4 iron. Remember, all of these coefficients in your reaction are numbers of moles. So that's not just 4 iron, that's 4 moles of iron. So 4 moles of iron up here, that's going to be 4 moles of iron down here in my fraction. And when I cross my bridge, it's pointing at 2 moles of Fe2O3. So I'm going to put 2 moles of Fe2O3 on top of my fraction. We need to use moles 4 times, twice with each chemical. Here it is twice with iron. Now here's moles of Fe2O3 once. The second time for Fe2O3 is going to be in my answer. And if you go ahead and calculate that, 4 times 2 divided by 4, you're going to get 2 moles of Fe2O3. Let's look at number 2. Number 2, how many moles of CO2 will be formed when 15 grams of Fe2O3 reacts completely? This problem has moles and grams. That's going to be a 3-fraction problem for moles and grams. So I can go ahead and draw my 3 fractions. This time they're starting me with 15 grams of Fe2O3, so for number 2, my bridge is going to start at Fe2O3. And that's my given that I'm going to write over 1. They're asking for moles of CO2, so my arrow, my bridge for number 2 is going to come point at CO2 in the reaction. To continue from here, I know that what goes up must come down, so grams of Fe2O3 will move to the bottom of my next fraction. At this point, I cannot get on the bridge yet. Recall that the bridge is always showing me a number of moles. Right now I have grams of Fe2O3. I can't get on the bridge until I have moles of Fe2O3. So I cannot use the bridge yet. However, I do know that I have grams of Fe2O3 on top and on bottom. Now I have used it twice. I can't use grams of Fe2O3 anymore either. So I'm going to have to switch. When I switch, if I'm thinking about I eventually want to be able to get on the bridge, maybe I should switch to moles so that I can use those moles to get on the bridge eventually. When we have a fraction that is moles and grams together, this is when we're kicking it old school, and you're going to fill in this fraction like you would have in our moles unit in Unit 8, where the number of moles used to always be 1, and the number of grams comes from the periodic table. So we're going to have to take a brief little sidebar here to find the mass of Fe2O3. If you check your periodic table, the mass of iron is 55.85. The mass of oxygen is 16. There are 2 irons and 3 oxygens, so you're going to have to add all of that together. And when you do, you get 159.7, which is your number of grams of Fe2O3. So that number of grams is what we're going to put down here at the bottom of this fraction. Then we know that what goes up must come down, so moles of Fe2O3 will move down to the bottom of the next fraction. Now, when I have moles on the bottom, I'm ready to use my bridge. Once you have moles on the bottom, you're ready to use your bridge. So I go look at my bridge, and it has me looking at 2 moles of Fe2O3, so I'm going to put a 2 here. If I cross the bridge, it's pointing at 3 moles of CO2, so I'm going to put 3 moles of CO2 here. Now, if you notice, we've used moles of Fe2O3 twice. We're done with that. We've only used moles of CO2 once, so I'm going to have to use it one more time, and that last time is going to be in my answer. So that moles gets used a total of 1, 2, 3, 4 times, and it's twice with one chemical, twice with Fe2O3, twice with another chemical, twice with CO2. And then, of course, we need to actually put this in our calculator. 15 times 3 divided by 159.7 divided by 2. Remember, anything on top you multiply, anything on bottom you divide. And you should get, it should round to 0.14 moles of CO2. When we look at number 3, what is the total number of moles of Fe produced when 5 moles of C react? We see moles and moles. That's going to be 2 fractions. So 1, 2. They're giving me 5 moles of carbon, so that's going to be my given that I write over 1 on my first fraction. And I also know that that's where my bridge is going to start for number 3 with carbon. Number 3 is asking us to find total moles of iron produced, so my bridge is going to point at iron for number 3. When I return to my fractions, I know that what goes up must come down, so moles of carbon will move to the bottom. When I have moles on the bottom, I'm ready to follow my bridge. So I look at my bridge, it says that I'm starting with 3 moles of carbon, so that 3 is going to come down here. If I follow my bridge to the top of my fraction, it's pointing at 4 moles of iron, which is what I should write on top of my next fraction. I'm supposed to use moles 4 times. I've used it 1, 2, 3 times, twice with carbon, only once with iron. So the 4th time I use moles needs to be in the answer with iron, so that I'll have used it twice with iron as well. And if you calculate this, 5 times 4 divided by 3, you should get 6.66. It should round to 6.67. 6.6 repeating, we're rounding to 6.67. For number 4, how many grams of CO2 are formed when 4.5 moles of carbon react? for the sake of space, I'm going to briefly rewrite the reaction down here just because mine got very crowded at the top and I have a lot of space down here at the bottom. I might as well use it. So I'm just copying this down from up here just because it's getting real crowded with bridges up there. So in this problem, they're asking me to start with carbon. So my bridge is going to start here. They're pointing me over at CO2, so my bridge is going to point there. And since this is grams and moles, I know this is going to be a 3 fraction problem. 4.5 moles of carbon is the given. So I'm going to put that over 1. I know that what goes up must come down, so moles of carbon will be down here. Once we have moles on the bottom, we're ready to cross the bridge. So I go look at my bridge. It's starting me with 3 carbon, so I'm going to put that 3 here. I cross the bridge. It's pointing at 3 CO2, but not just 3 CO2. Remember, the bridge is always telling me numbers of moles. So that's 3 moles of CO2 that I'm going to put on top of my fraction. Okay, I've now used moles of carbon twice. Can't use moles of carbon again. I've only used moles of CO2 once. So now I know that what goes up must come down, and that's going to be the second time I use moles of CO2. I'm done with moles of CO2. I can't use it anymore. But I do know that they're asking me to find grams of CO2, so why don't I put that on top? What they're asking you for should always be on top of your last fraction anyway. When you get a fraction that is grams and moles together, we're kicking it old school here. This is just like what you would have done in our previous unit, where our number of moles is 1 and our grams come from the periodic table. So you would go look at carbon on the periodic table and at oxygen. There's only 1 carbon on the periodic table. Each carbon weighs 12.01 grams. There's 2 oxygens, and each of those are 16 grams on the periodic table. When you add this up, you get 44.01 grams, which is going to be the number of grams of carbon dioxide that you use in your fractions. So the last thing to do is to multiply this all out in your calculator. And I get 198.045, which rounds to 198.05 grams of CO2. Notice I have used grams of CO2 twice as well. Everything's been used twice. Moles of carbon twice, moles of carbon dioxide twice, grams of carbon dioxide twice. So I'm done.